All right, we've been marching down the road of inequalities, linear inequalities, and now we come to solving absolute value inequalities. And if you recall, when we were solving absolute value equality statements, equations, we had to set up two cases. And since we're going to have to set up two cases, then this is going to function much like a compound inequality that we just finished studying, where we're going to have and or statements. And as we're dealing with absolute value inequalities, the inequality statement itself gives us a clue as to whether we're dealing with an and or an or statement. So if you think about phonetically, when you hear less than, and, we hear an and phonetically we hear and, less than, and then greater, or is an or statement. So our less than absolute value inequalities are going to be and statements, and our greater inequality statements are going to be or statements. Now, one thing that we have to do differently than when we were solving absolute value equations is when we set up our second case, we're going to flip this inequality. So let's start here at the beginning. All right, so we got absolute value of n minus 8 is less than or equal to 2. So I'm just going to set this up initially as n minus 8 is less than or equal to 2. We're going to add 8 to both sides. Over here on the left, it's going to cancel, and we're left with n is less than or equal to 10. And now I'm going to work on the second case. Now, ordinarily what we would do, and we're still going to do, is we're going to initially set this up as n minus 8 negative 2. But because I'm changing this to, this is particular to inequalities, from a 2 to a negative 2, I'm going to flip this inequality to greater than or equal to negative 2. Got to flip the inequality. In your book, where it's talking about the inequality in that example that's located on page 312, they do it like this, and I'm going to do it just for illustration purposes. It starts off with negative n minus 8 is less than or equal to 11. Then they divide everything by the negative 1, and we're left with n minus 8. And we know that when we divide by a negative number or multiply by a negative number, we have to flip the inequality. And so that's in essence what I did right here. I just went ahead and flipped the inequality. Now I'm going to solve. I'm going to add 8 to both sides. Over here on the left, it's going to cancel, and we got n is greater than or equal to 6. All right, now if we were to write our answer here in set builder notation, we would write it such as this. This is an and statement, so it is the union of the two solution sets, where we would say that the solution set is n such that 6 is less than or equal to n, and n is less than or equal to 10. And if I were to draw that on a number line, and let's say right here we got 6, and here we got 10, if I were to graph this on a number line, and I've got a less than or equal to on both sides, so I've got closed dots, so that my solution set, where n is less than or equal to 10, but greater than and equal to 6. So solving absolute inequalities, when you set up your second, you're going to set up two cases. When you set up your second case, you're going to flip the inequality for the second case and solve. If it's a less than, it's going to be an and statement. We're going to see in a moment. Greater is an or statement, or the intersection of the two solution sets. Now, let's look at one more before we leave here. This will be brief. Here we got the absolute value of 2c minus 5 is less than negative 3. Well, absolute value of anything cannot be negative. Whatever comes out from underneath these absolute value symbols cannot be a negative number, and so therefore in this case this is just an empty set. There is no solution.